Hi. Today I would like to talk about extension methods in Unity. It's one of the line of code substitution techniques you can use. The reason why I want to talk about this in my second video is I am going to use some of them a lot in the future videos, and also I think extensions are huge time savers when developing games or any other software actually. So what does extension mean, right? What does it mean? The extension functions are your utility codes for classes that you use oftenly, the object processes that you do very oftenly. You make these functions when you're redoing a process on an object over and over again, right? When it is too expensive, but there are also like other techniques of substitution, uh, like encapsulation into another class. But when it is too expensive to encapsulate a list of simple actions on an object to a class, uh, that's when we use extensions, right? So these extension methods act like they are defined under the type you are extending, but they are actually just static methods. Um, right? So, also a small warning: not to overuse them for everything. You should still write your code explicitly when extensions doesn't help you that much, because if you think about it, extensions are actually a dependency. Excuse me. So if other people are going to use your components or something, they need to have your extensions, right? They need to have your extension class. So you create a dependency to your extension class as well. And if you're a team, like working as a team, they should also use it, right? Right. So you cannot have like implicit some sort of like extension method usage and still using the same pattern with like explicit in an explicit way. So um, it's something to think about. Also, a small warning. The biggest example of this extension methods are actually you can see it in system link queue library, right? For collection and lists, uh, we have these extension methods for a lot of query making stuff like query operations. Select from where you you write where, and you get the first or default, like some sort of you have like a um, uh, condition, and you can pull some of the elements based on the condition and just use them. Um, they are best used when you have like you are making these with abstract types, right? Like interfaces, like LinkQ does, LinkQ library does, IEnumerable, IEnumerator, like those kind of stuff. They are using iCollection, and they're using iCollection, iList, or something like that. All of them actually, most of them are actually abstract in System LinkQ library. They are using abstract types. But for now, I just want to show the syntax and how I would come up with a decision to making an extension, because we cannot really have for Unity types, we don't have abstracts. We just have the implementations like transform or rigid body or something like that. Those components are actually implementations. So we just gonna have to make extensions for those maybe. Okay. Um, so I have here a scene with spaceship stuff. Let's assume these are spaceships, okay? And I'm going to also talk about this setup that I prefer to use in a different video. Uh, but what they do when I run this is they target their turrets to each other, right? I have player here. They will target their turret to each other, and I want to have a constraint for turrets. I only want them to rotate around the y-axis and not x and z-axis. So they will not rotate around the x or z-axis, right? Okay. So let's look at the code for this. It's a very simple code actually. It's just showing this use of extensions. It's not really functional too much, but it works. Okay, so we have here a targeted spaceship, and I am getting this. I'm calculating a direction, and I'm just putting the direction in, right? So that's pretty like easy, and it's just one line of code. The problem is sometimes people can uh, like mistake this and write this to the right side, right? And like get confused or something like that. So you could actually provide a extension method to prevent these things, and it would be also easier to read. So we could do an extension method for this, and we could also make extension method for this as well. We could really simplify this. Also, maybe you know this, but vector tree is one of the most popular type for making an extension in Unity. The reason is really simple. Actually, for vector trees, we use them a lot, and because it's a struct and not reference type, we have to recreate it and assign it, right, with a new keyword. Even if we only want to change one axis like this, right? We are changing two axes here, the just the x and the z, but we have to recreate and assign it to local Euler angles. Okay, so for this we have like a very popular extension method which is called width, right? Width. So I have some of the extension method examples here. We're gonna make our own reason, but I just want to show the width thing over here. So as you can see, this width is just uh, like we just need only have to set what we want to change, and the rest will just be the values of this vector, like it will continue. And we achieve this by nullable parameters over here, right? Nullable parameters syntax is like this. So we are so float question mark x equals null. So what we are doing here is uh, we are saying this is really not necessary to assign. We are saying that to the user. This is not really um, required to assign. And what we have to do is just place x over here and have a two question marks. This is like asking if x is the x is null. If so, then use the right hand side value. If x is not null, then use the x that we receive, right? So this is the how we use nullable parameters like this. So with the width value. And let's make that actually. Let's use that. So what I want to do is I want to assign with the only with the y, right? And also remember this. We could also have like make mistakes over here. Maybe write like x or z or something like that. So this extension also prevents from that happening, right? So um, this is a good idea to use extensions over here. So let me write turret transform local Euler angles and with x 0 and z is 0. So we are not going to make mistakes like this, right? It's just very easy, also very easy to read. It's very like logical to read also. Like we are just saying, I am assigning a new vector tree with x is 0 and z is 0, but I'm not touching a y value. So it's really logical to read. And okay, so we can even for this we can do a better approach actually, and let's do that. So how can we do that? So there is like direction to value. We can also see the distance too. So by this I just have like different versions of this as well, like transform vector tree to rigid body vector tree transform. You can do as much as you want. It would just work actually. So let's from our transform, let's get the direction to our targeted spaceship, right? It needs to be transformed, sorry. Okay, so from our transform, we're getting direction to targeted spaceship transform. It's much easier to read, and it's logical, and it is less prone to error. So this is the reason I made an extension for that also, and I'm using it this a lot. Okay, so we can further substitute this, right? We can even further substitute this. Let's substitute that. Let's say this is a public. By the way, if you are making extensions, it has to be in a static class. And you can put whatever name you want, but it has to be a static class and public static. And what do I want to do? I want to change the transform value, right? I want to change. Let's put this over here. So what I want to do is assign the transform a new rotation, right? So I'm going to write target 2. Sorry, I forgot about this one. So my type that I'm extending is that transform, right? And then what I want is a direction, vector 3 direction. I want the target to a direction. So what I can do, I can just copy this over here, right? I can just copy this over here, and then I could just actually delete these and delete these, and I could also mimic my width function over here, width method over here. So I could just go. Let's see, I could just get these nullable values, nullable parameters, and just copy them over here, and then just say z, z, and maybe I have y to y, right? Okay, then all of this simplifies to this target to direction, and I want x to be 0, and I don't touch the y. I only want z to be 0 as well, and that's it. It's simplified to this line only. So you can do like a lot of stuff with this, and maybe you could make like check for null, and if it is check for a get component. If it is null, do this action. If it is not null, do this action, kind of thing. Like you could also simplify to that as well. Like maybe from targeted spaceship, you want a certain type, but it is not available, you could just make an extension for that too. The way we do that is just get component. Let's say rigid body, right? We want to get rigid body, but if it doesn't exist, we want to just do, maybe we do nothing, but maybe we do another thing, right? So rigid body, and the way we do that for now is like this. So rigid body equals this, and then we just check if it is null, uh, equals the null. Do here something. If it's not null, do something else over here. So debug log not null, and debug log. Oh, sorry. Debug log null, and debug log not null. Yes. Also, don't do this in update method. I am doing it in an update method, but I am just trying to prove a point. But let's just make it in a start function. Okay, so I'm doing it in a start function, and I am doing something in like null or not null, right? And it's occupying a quite a space, as you can see. What I can do is just make a generic extension, so public static, and I can just do void, and I can just have the do this kind of thing, like um, let's say protected action, right? And I am going to make this generic function, generic method, and the type is actually this, what we are actually getting, right? The component. Actually, we are only going to use this on components or game objects, but we have to make the different well, for game objects. So let's do this for only for components for now. My component, right? I could also directly write this as like a component, like explicitly write the type, but I'm just going to do this unity action, and also I could also return this here as well, the type that I receive. I'm going to just include the event library, and if I do have this not null action, let's say this is the null action, I don't have anything here. This is also a unity action. This is not null action, and yeah. So now just copy this over here, right? I'll just copy this over here. Now what I do, I'll just set the component. Also, yeah. Actually, this is kind of like a component. Yeah, component. I made a mistake there. This is actually just a component. So this is the component we want. This is the return type, returned component, right? Because we're gonna get component T here. So this is how we should use this. Return component this, and I'm going to return the returned component, right? Also, and if it is null, I am going to do the null action, right? Invoke, right? If it is not null, I'm just going to do the not null action, and that's it. And I could return the component, and I could just do simplify this to this. So transform dot get component, no, targeted spaceship dot get component, no, protected action, yeah, and basically I could just not for null action I am just going to say debug log um, null, and for other action which we have type debug log log not not null, right? This is just how we actually uh, should come up with. Okay, I have some error. Let me see. Arguments, type arguments explicitly. Okay, so I have to get component, right? I have to say get component. I forgot about that. So I'm not, because this is not the same as this one. It is not going to take it automatically. So I have to do rigid body. Let's say rigid body. So now this should work. Yes. Okay. Then I could just get the type of this, and as you can see, the parameter now turned into the rigid body. Yes. Okay, I hope you enjoyed it. This was all for like today. Um, okay, bye.